So we're going to start similarity and transformations today. It's just an extension of what we were doing yesterday. So if you understand those similarity things that we were doing yesterday, you're going to be good to go today. Basically, it's an extension of the chapter because all you're doing is now adding another transformation, which means it's a dilation, but then it's also another one. And it's, to be fair, usually just a rotation. I have misplaced my black pen. No, there it is. Okay, so that's the only difference between 4.5 and 6 is that you're going to do another transformation. Got my name on my paper. Hopefully you've gotten yours printed by now. Here's our objectives. I want my students to be able to identify similar figures and perform similarity transformations, which we will practice to right now. Transformations. Okay. A dilation is a transformation that preserves, as we know, shape, but not size. Okay? So as we know, it either makes it bigger or smaller, enlargement or reduction. So what the word we use for that is non-rigid. Remember, our other transformations in Chapter 4 were rigid transformations. These are not, because it changes shape. Just again, so a similarity transformation, it's a dilation or a composition of rigid motions and dilations. So it's a combination. Okay, so it just changes the shape, as we know. The difference is we're calling this a similarity transformation. What we did before and what we're doing in this new chapter is we're doing congruence transformations. That's what we've been doing. So the difference, of course, is that those preserve both length and angle measure. Okay, a similarity transformation only preserves angle measure. So you can compare those two. Now, similar figures are two geometric figures if and only if, remember it goes both ways, there is a similarity transformation that maps one of the figures onto the other. So similar figures will always have the same shape, but not necessarily the same size. So it's italicized, it's underlined, bam, hopefully that is sticking in your brain. I've said it like 5 times already. But if you think about it, if a dilation has a scale factor of 1, what are the values for K so that the dilation is also a congruence transformation? Well, it's when it's 1. Okay, or there's another possibility. What else can K be to make it congruent? We talked about this yesterday. It can also be -1. Because remember, the negative rotates it 180 degrees, and the 1 means it's the same size. So this is like a rigid motion that just moves it around. So when the scale factor of the dilation is not 1 or -1, then similarity transformations preserve angle measure only. So again, I'm just sort of hitting home the next point again. Feel free to raise your hand or ask a question at any time. This is me pausing. Okay, so what I'm going to do here is, like yesterday we did some dilations, This you're doing the combination, which of course is called a composition. We're going to graph the first one in black, I'm going to graph the second one in red, and I'll graph the third one in blue. So it's 3 different graphs. We're going to start with ABC. A is -4, 1. B is -2, 2. And C is -2, 1. So we've got this teensy tiny triangle. Put that right along with me. And then I'll do the second one in red. My translation rule is here. So what I'm going to do is I'm going to put A prime, B prime, C prime here. Well, I'm not going to do the arrow yet. Okay, so I'm going to take these and I'm going to add 5 to my x's, and I'm going to add 1 to my y's. So that makes A prime. -4 plus 5 is 1. And 1 plus 1 is 2. B prime is going to be -2 plus 5. And 2 plus 1 is 3. And then C prime will be -2 plus 5. And 1 plus 1 is 2. So let me go ahead and graph that. So A's 1, 2, that'll be my A prime. 3, 3, that'll be my B prime, and C prime will be 3, 2. And then blue. Now I'm going to dilate, again, because it's a composition. So basically, I'm going to double everything. So that means A double prime will be 2, 4. B double prime will be 6, 6. C double prime will be 6, 4, because I just doubled all those numbers. And now I'm going to put it on the graph. So A double prime, 2, 4 goes here. 6, 6 will go here. And then 6, 1, 2, 3, 4 will go here. See how those colors just make it pop right out? And so because it's more than one, you can see they're all the same shape, but clearly this one's bigger. And that is a similarity transformation. We're going to do another one. And instead of it getting bigger, you may guess this, it's going to get smaller. So let me turn the page. Hopefully you're all ready for this. As you can see, this is just a line. We're going to graph, or a segment. So we're going to graph CD with these vertices. Okay, C is -2, 2. And D is 2, 2. Connect those. And it's image after the similarity transformation. The first thing we're going to do is a rotation. So if you don't remember the rule for a rotation 180 degrees, it's going to take your x's and your y's and it's just going to change the signs. So that means that C prime is going to be +2, -2, and D prime is going to be -2, -2. So let me put that on there. 2, -2 will be C prime. -2, -2 will be D prime. See how even though it looks like a translation, it is a rotation because C is over here now and D is over here now. So that switches that. And of course, the last one is going to be the dilation, and we're going to make those a half. Okay, so now C double prime is going to be 1, -1, and D double prime is going to be -1, -1, because I just take half of those numbers. So 1, -1 is here, which is C double prime. -1, -1 is here, which is D double prime. And there you go. There is your similarity transformation with both a rotation and a dilation. Any questions? You'll be doing that. It'll super duper help you to have graph paper and colors for this. The other two examples, what we're going to do is we're going to describe the transformation. So we're going to look at what happens and see if we can figure it out. So it's the exact opposite, but we know that a similarity transformation happens if and only if. So I'm going to take a look at these. It's telling me that the big one, or the pre-image, is PQRS, and the image is WXYZ. So I'm just going to mark it that this is my image, and this is my pre-image. It's the first one. And I want to describe what's happening. Well, clearly I can see that this one's getting smaller, so I know I'm going to do a dilation. I'm going to do that second, actually. And do you notice how it's flipped? That's actually the Q and the X are the ones that line up, the P and the W. So this is actually a rotation of 180 degrees. You could also say, oh, it's not a rotation of 180, it's a rotation of like 90. Sorry. Actually, what it looks like is it looks more like a reflection. Wow. We all make mistakes. We're going to fix that. This is a reflection in the y-axis. It just went from here to here. Okay. Now the dilation thing here, once you reflect it, I'm going to use a different color here. If you reflect it, remember these are the same distances from the reflection. So this has a distance of 3, which means if I was going to flip it, here would be like your Q prime. 1, 2, 3, 4, 5, 6. Here would be your P prime. It'd be your R prime, and here would be your S prime. So this is what it would look like first on my reflection. Then what I'm going to do is I can, let me just make sure that I get green there, so we are double coated here. And then if I want to make it smaller, clearly, I'm going to make this one smaller. How much smaller is the blue than the green? Well, this is where your K comes in, because you figure out what your K is by comparing, remember it's the image, it's the image divided by the pre-image. That's our definition. And it can be any one of the sides. So see how QP is 3 and XW is 1? That tells us we have a dilation of 1/3, which means, here's the rule. Bam. That's it. That's your description of a similarity transformation. Okay. And again, pop up your hand or unmute yourself if you have questions. We're going to do another one here that's slightly different. It is going from the big one to the small one again. Okay, so we do know it's going to be a shrink. But here's our pre-image, here's our image. You may be able to tell that because, let's see if I can do this with the right color. Because F is over here and U is over here. See, if this is my center of rotation, then F has gone all the way over here, G has gone all the way over here, E has gone all the way over here, and D has gone all the way over here. So the first similarity transformation that's happening here is a rotation about 180. Well, it's a rotation 180 degrees. And remember, we always say about. We have to say where it's from, and that's about the origin. And that's another word for around. It's around the origin. So that's our center point right here. The other thing that's happening is it's getting smaller, right? So we do know that it is getting smaller. And one of the things we can do is compare the distance from the center. So the rule we're going to write about is how much are we going to dilate? Well, here's what I would do to figure out my K. It's the image over the pre-image. So this image, F, is 4 away from G. And this image, U, which corresponds, is 2. I just put it backwards. It's not going to get bigger, it's going to get smaller. It's the image, which is 2 over the pre-image. It's getting smaller. So from here to here is 2, from here to here is 4. That gives us a scale factor of 1/2, which means both of these, the rule is we're just going to take half of those numbers, okay, and do that. And we'd be done, except there's one more thing I want to say on this. Does anybody remember from 4.5 lessons, how could I write this translation in just one way? In other words, I wrote 2 steps, but there is one way that I could write this rule with just 1 step instead of 2. In other words, what notation for K did we use yesterday that will rotate it 180 and dilate it at the same time? Does anybody remember?
-1/2.
Very good. Very good, thank you. And that's exactly right. So you can either write it like this, these 2 answers, or you can just write it like this, because that saves a step, that's all. And so what you're going to be doing in Big Ideas is you're going to be either identifying what's happening, or you're going to be drawing it yourself. And of course, if you have questions, you can rewatch this.